Okay, so I have shared the whiteboard. Right, today this is the last class for pure maths and for integration as well.
Okay.
Today we'll talk about improper integrals. Okay, this is what we need to study today, okay? So we have been doing integrals. We have seen how to integrate in different situations. We know how to find the shaded region. We are clear with that. Now we need to
Mm.
understand one thing, that what exactly are improper integrals, okay? So we have
Yeah.
two types of improper integrals. Let's just start the discussion with type 1. Type number 1, okay? So as I told you earlier, we have two types of improper integrals. This is the first type, and the first type is, for example, if you have been asked to integrate from 0 to infinity 1 over x squared with respect to x. So let's say you've been asked to integrate from minus infinity to minus 2, and the function is 1 over x cubed with respect to x. Okay, right. Now what exactly is the thing and why are they improper integrals? I'll tell you. They are improper integrals because of the limits. Okay, if one of the limits, like if I talk about the first example, this limit is infinity. If I talk about the second example, the lower limit is minus infinity. If one of the limits is infinity, that integral is considered as an improper integral. We'll see how to calculate it, but for now what you need to understand is the distinction between a proper integral and an improper integral. Okay, if one of the limits has this infinity in it, that would be an improper integral, right? So this is the type 1. We'll talk about type 2 once we are done with type 1. Okay, so did you understand?
Yes, ma'am.
Okay, now yes, with infinity the evaluation of the integral could be difficult, but I'll talk about an example and I tell you how to compute an improper integral of type 1. Okay, so
Okay.
let's talk about an example. Haris, please ask me if you have any questions. Okay, so let's talk about example number 1 for this. Show that the improper integral from 1 to infinity 1 over x squared with respect to x. Okay, this is the integration which you need to do. Show that the improper integral, this, has a finite value and find this value. Okay, now please pay attention. This
Okay.
integral is certainly an improper integral because we have infinity in the limits. Okay, this is how we distinguish between a proper integral and an improper integral. Okay, now the integral is improper certainly, but they're saying that we need to show it has the value of this integral is finite and we need to find the value. So how do we do it? Let's see. So we have a fixed method for this type of questions. Okay, step 1 is to replace infinity with x. Okay, so I will write down capital because we already have an x here, so that would be confusing. So that is why step 1 would be, I'll write it down here, replace infinity with capital X. Okay. So we will write down the integral again with 1 capital X 1 over x squared dx. Okay. This is the first step. Step 2 is to integrate it. Now, obviously, we know in order to integrate it, I need to simplify the function. That is, I need to have the x in the numerator just so I can integrate it easily. Now I am in the position of integrating it. So the variable would come as it is. The power would come as it is, plus 1 divided by the new power, that is minus 1. And the limits of the integration are 1 and capital X. I'll rewrite the function properly. So it is basically minus 1 over x, and I need to integrate it from 1 to x. And now I can just plug in the limits and see. Okay, so this would be, I'll plug in capital X, it would be 1 over capital X minus 1 over, yeah, okay, minus, and now I need to plug in this limit. So it would be minus 1 over 1. And now I'll simplify this. So minus and minus would be cancelled. Minus 1 over capital X plus 1, and I can write it as 1 minus 1 over capital X. And we are not done yet. This is what we did initially, and we need to do this step again as capital X is infinity. So 1 over capital X would be what? It would be anything divided by infinity would be what?
0.
Very good. Okay, this would be 0. Haris, did you understand this? Okay, very good. Acha, this is 0. So the answer is going to be 1 minus 0, that is 1. Okay, so basically this was the question. Step 1 is to see if it is a proper integral or not. Before this class we only had proper integrals, so we are comfortable with that. It is not that different, the integration procedure is same. The only thing is that when we talk about definite integrals, we have two limits. If one of the two limits is infinity, that integral is considered to be an improper integral. Okay, now step 1 would be this one, replace infinity with x, do your basic integration the way we do it, and once we are done with the integration, just plug in the limits. Since one of the limits was infinity, just see what would be the value of this thing and then just write down the final answer. Okay, this is the first question. Yes, any doubts in this question? All right, okay. Let's talk about another example now. Okay, wait, Haris. Okay, the last part. Okay, Haris, this is the last part. Okay, so basically, once we plugged in infinity, instead of x, we got 0. Okay, so this was 0 and this is 1. So 1 minus 0 is 1, right? We were integrating it. This was the final answer, but we were not done yet because we had x here in the question, we had infinity. So we need to replace x and infinity. Once we plug in infinity, we just need to simplify it and then just write down the answer. Okay, did you understand it now? Okay, very good. Okay. So we are talking about the type 1 of improper integrals where one of the limits is infinity. This was the first example. Let's talk about another example. And then we'll talk about type 2. Okay. Acha, I'll write down the question. Again, it is, you need to integrate from minus infinity to 0, and the function is 1 over 1 minus x cubed with respect to x. Okay. Okay. Now what do we see? Step 1 is to identify if this is a proper integral or not. That is very easy, right? This is certainly not a proper integral because one of the limits of integration is infinity. Okay, so this is infinity and this is basically an improper integral. So I know how to deal with improper integrals now. I'll again do the working. So the solution is going to be of this type. Step 1 is to replace this limit with any other variable. You can use capital X, you can use A, you can use B, you can use P. It is completely your choice. Okay, so I am going to replace minus infinity with, let's say, P. Okay, it could be any variable. It's completely your choice. Okay, it's totally your choice. Okay, I'll rewrite the question with this limit now. Okay, now we need to integrate it. How do we integrate it? We know in order to integrate anything, first it's good that we write the function in proper form, just so we are in the position of integrating it. So I have taken this factor from the denominator to the numerator with negative power. Okay, just so it's easier for me to integrate. In case of any questions, please stop me there and then ask me. Okay, right. Next step is integration. Okay, so I told you earlier as well, how do we integrate such type of functions? I'll write down the bracket factor as it is. I'll write down the power. I'll add 1. I'll divide it by the new power. This is minus 2. And I need to divide it by the derivative of this function. What is the derivative of 1 minus x? Yes.
1.
Minus 1, okay? Because we have minus x. So it would be minus 1. Did you understand, Munja?
Yes, ma'am.
Okay. All right. So it would be 1 minus x to the power minus 2 over 2. I need to write down the limits with every step. Once we are done with the integration, we write down the limits here from 0 to p, from 0 to p. Okay. Now I'll just simplify this just so it's in an understandable form, and then I'm going to integrate it. Then I'm going to plug in the limits. I'm sorry. Okay. Yes, this is what I have. Okay, now I need to plug in 0 first. So I'll plug in 0 and this would become 1 over 2, 1 minus 0 squared. This is the first limit. Then minus sign, and I'm going to plug in p, 1 over 2, 1 minus p squared. Bracket close. Okay. This is going to give me 1 minus 0 is basically 1. So it would be 1 by 2 minus. And what am I going to get from the other function? So let's write it as it is. It would be 1 over 2, 1 minus p whole squared. And we are not done yet, okay? Again, since in the very beginning, we replaced minus infinity with p. So now I am going to do that again as p is minus infinity. So what about the function? P is minus infinity. So 1 over 2, 1 minus p squared would be what? Yes. If I'll plug in minus infinity here, what am I going to get? I would get infinity in the denominator. Anything divided by infinity is what, Haris? Yes. We have just done this. Anything divided by infinity. Okay. It is 0. Very good. Excellent. Okay. So this would be 0. And this would basically become 0. And the answer is going to be 1 by 2. This would be the answer of the integral. Yes. Any doubts in this? Anything that you have not understood, Aditya, Haris, and Munja? Please tell me.
Ma'am, I think, where did I get lost a little bit? On one of, on what step one, number one, step number one, step number two, step number three. On step number 3, from the pen, from the ready pen. So
Okay,
step
okay.
number 3.
This step?
No,
This one.
on the right. Yeah.
Okay, all right,
So
all right.
step
Okay.
number
You're
3.
confused with the integration, okay? Right? You're confused with the integration?
1/2.
Wait,
Okay.
wait. You are confused with this step?
No.
No. Okay.
Again down this,
This
the
one.
third step from that. Yeah.
This one?
Yeah, that's the one.
Okay, all right. Okay. So this is what I got after integration. Okay. I had 1 minus x to the power minus 2 divided by 2. I've just taken this factor from numerator to denominator. Just so I have this 2
Okay.
with positive power. And while plugging in the values, I'm able to, plug in the values and simplify it easily. Okay. I've just done this for my convenience. Just like I
Okay.
had positive 3 here, and I took this to the numerator just so I have everything in numerator, and that is how we studied integration. Okay. So just
Okay,
once I was done
understood.
with integration, I just took this factor to the denominator. Okay. Right. So Aditya,
Okay.
next question is from Aditya is saying that, let me read the question again. Can you explain how anything divided by infinity is 0? Okay, I'll tell you. Look at this. So let's say we have a number, we have 2. 2 divided by 10 is 0.2. Okay. 2 divided by 1000 is 0.002. 2 divided by 1, 2, 3, 4, 5, 6, 7. If I divide 2 by this number, it would be 0.0000002. Okay. So infinity would be a number much, 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 much bigger than this. Okay. Infinity is the world's biggest number. We do not know what number it is exactly, but it is the biggest number. So what is the pattern? The pattern is that when the number in the denominator, when it is increasing, when it is getting bigger, the overall answer is getting very, very small, right? This is what you need to understand. So this is a logic. This is how we do. This is how mathematicians have decided to, take infinity. Any number divided by infinity is 0. This is a rule, okay? And this is how we do it every time, right? So is it clear now?
Yes, ma'am.
Okay, let me see. Okay, very good, Aditya. Okay, now I repeat, this was the type 1 of improper integrals. How do we distinguish? This is how we distinguish. If one of the limits has infinity in it, it is type 1 improper integrals. Okay, let's talk about type 2 now. We are done with type 1. We know how to do it. We need to do this step. We need to integrate it. And once we are done with the integration, we need to do this step again. Find the value of the function that has infinity in it, like we replace it with p, and then just use this value in the final answer to find it. Okay, so this is how we do type 1 improper integrals. All right, let's talk about type 2 now. Okay. Type 2 of improper integrals. Okay. Now, what exactly do we have in that case? Okay. They are integrals with simple limits a and b. It could be any number. The function is f of x with respect to x. But what is the problem? Problem is that f of x is not defined on either a or b. Okay. Right. Okay. Now this is the second type of improper integrals. What is the idea? The idea is now in this case, the limits are okay. The limits are any two numbers. It could be a positive number, negative number, zero. That does not matter, but it is not infinity. Okay. The limits are good. The issue is with the function. The function is not defined on either the lower limit or the upper limit. I'll give you an example and then things would get clear. Let's say we have 1 over x squared with respect to x, and the limits are from 0 to 1. Okay. Now, 1 over x squared is not defined on 0. Okay. If I do it this way, it would give me 1 over 0, and this is going to give me what? Anything divided by 0 is infinity. Okay. Anything divided by infinity is 0, and anything divided by 0 is infinity. You can also understand it this way. If I take 0 here, if I take infinity on the other side, so it would be 1 over 0, and that is infinite. You can, it makes sense as well. If you are dividing a number by the world's smallest number, then it would give you infinity. And if you are dividing a number by world's largest number, then that would give you 0. Okay. Yes, this is the idea. Now again, this is the second type. What do we see? We see that the limits are okay in this case, but once I'm plugging in the lower limit, that is 0 in our case, we are getting infinity for the function, and function is not defined. Okay, this means the function is not defined at 0. So this is the type 2 of improper integrals. So yes, is this okay? Yes, Haris, Munja, and Aditya, please confirm if you have understood this or not. Okay, and what about other students? Haris, sorry, Munya and Aditya, is this okay? Munja, I'm not able to hear you. Your mic is mute. Okay.
Sorry. Yes, ma'am.
It's okay, right?
Mm.
Okay, yes, I can give you an example in graph as well. Okay.
Okay, thank you.
So yes, let's talk about the same graph. The graph for 1 over x squared, okay? So this is the y-axis. This is the x-axis. And now I'm going to make the graph. This is y, this is x. Okay. The graph of this function is something of this type. So we have two asymptotes in this case. Okay. So what do you see? You see that this is x equals 0. This point is x equals 0. You do not have any value for y on x equals 0, the graph is not touching the y-axis, or it is not going to touch the y-axis, right? Are you guys familiar with these types of graphs?
Yeah, kind of.
Okay, so yes, this is the idea. If I talk about this function, let's say if I talk about one over x, okay, now this time it's simple 1 over x. So what is the shape of the graph in this case? Yes, can anyone tell me what do we get for 1 over x? No? Okay, I'll tell you. So the shape is similar, but the quadrants are different only, okay? This is what we get in this case. Again, the graph is not defined on x equals 0. And we can see that from here as well. If I plug in 0, I will get 1 over 0. That would be infinity, and infinity is undefined. Infinity is not defined, okay? This is how we know if the function is defined on a particular value or not. If for a specific value of x, you are getting infinity, you can say that function is not defined on that value of x, okay? So yes, through graphs, you can see it this way. Yes, Aditya, is that okay now? Okay, very good. Right. Let's see how we solve such questions. Okay. Let's talk about the first example. This is, we only need to do this example and then we are done with this. Example number 1, please pay attention. Find the value if it exists of this. This is the function. Okay. We need to integrate it now. So how do we do it? First thing is we need to see if it is a proper integral or not. Now I know that the limits are good, so it's obviously not the type 1. But if I look at this limit, it's very obvious that 5 by 0 would be infinity. This means the function 5 over x squared is not defined on 0. And this means that this is an improper integral. So how do we do it? Again, step 1 is to replace the lower limit with some other variable. So instead of 0, I am going to use capital X. Okay, we can use any variable, but you'll see in past paper questions that at times examiner is using capital X as well. Okay, that is why I just want you guys to be comfortable with all these different types of variables. But you can use P, A, B, anything. That would not matter at all. Okay. So I'll write down the integral again, 2 and then capital X, 5, and then I can write down minus 2 there, this way. Okay. This is what we have. Now I know how to integrate it. 5 is going to come as it is, x to the power minus 2 plus 1. I need to divide it by the new power. Minus 2 plus 1 is basically minus 1. And if I simplify this, Munya, please pay attention. It would be minus 5 over x. Okay, so this was x to the power minus 1. I've taken this x to the denominator just so I have it with a positive power. Yes, did you understand the step on here? It's just like the previous one thing which you did not understand in the last example.
Oh, yes, ma'am, I did.
Okay,
Thank you.
very good. Right, now we are not done yet. We need to plug in the limits 2 and x. And now let's just do it with the limits. So it is going to be, first I'll plug in the upper limit 5 over 2 minus and then minus 5 over capital X. And I'm going to simplify this. So minus into minus would become plus 5 by capital X. And now it is going to be 5 by capital X minus 5 by 2. Okay. What next? Next step is that since capital X is basically 0, so 5 by 0 would basically be infinity. Okay.
Mhm.
This means that if I try finding the value, 5 by x would now become infinity minus 5 by 2. Okay. So infinity minus any number is going to be infinity. This would be infinity. So the answer is that the value does not exist. Integration of 5 over x square from 0 to 2 would be undefined, right? So the answer is right. Did you understand this, all of you? What is the new thing? Everything is same in type 1 and type 2 except the distinction. Okay, here the limits were okay, but the function was not defined on one of the limits, so the limit was 0. So we replaced it with x, and again we replaced it with 0 once we were done with the integration. All the steps in between were same. Okay, so once we plugged in this 0, we got infinity, and this infinity is undefined. This is what I got as my final answer. And since this is not a finite number, so the answer would be that this is undefined. So obviously this does not exist. Yes. Any doubts in this? Mundya, Haris, and Aditya, please tell me if you have understood this or not.
Yes, I did, ma'am. Thank you.
Okay, very good. And what about the other students? Please confirm. Yes, please tell me. This is okay. In these questions, can't we just tell by looking that the integral doesn't exist? Yes, you can. But look, yes, obviously, I do understand the fact that it was obvious here. But since if the examiner is giving this question for 4 marks or for 3 marks, you need to do some steps to prove that. Okay, in most of the questions it would be that the answer is very obvious, but you need to show your working, you need to show such things that you know them, and then you can claim that this is why it was undefined. You need to do these steps. Okay, yes, is this okay, Aditya?
Yes, ma'am. Thank you.
All right, okay. All right, okay, so we are done with this. The last thing for this chapter is finding volume. Now what exactly are we doing here? I write it down. Okay, now so far we have been discussing that when we integrate something, we get the area under the curve. Okay, that is good. For example, I'll make a diagram. So this is the y-axis, then this is the x-axis, and here's the curve. Okay, and let's say we are integrating it between 2 points. Okay. Now the equation is y equals x squared. This is 2 and this is 5. Okay. If I'm interested in this pink area, I am simply going to integrate the function from 2 to 5 with respect to x. This is what we have been doing, and obviously it is going to give us the area. But what is the topic under discussion? The topic is volumes. If I talk about any 2D shape, square, triangle, trapezium, circle, all these are going to give me area only. If I talk about 3D shapes, yes, in that case I can talk about volume. Okay. So the idea behind this chapter, behind this section is that if you have this shaded region and if you start rotating this, okay, just imagine that you have this thing, okay, and you rotate it to an angle of 360 degrees, what exactly are you going to get then? I'll try making that thing now. So this is the y-axis, this is the x-axis. Okay, I'll make that shape. So it is going to be, I'm only going to rotate the shaded region. This point would be 5 and then this point would be 2. Okay. All right. Now this is a bell-shaped thing and this is 3D. Okay. It's not 2D anymore. It's 3D now. And what exactly is the idea? The idea is that I rotated this pink shaded region to an angle of 360 degrees and I got this bell-shaped thing. You can imagine this on your own as well. If you have anything 2D in front of you, let's say a card or something of that type, just rotate it, okay? Just rotate it and that would make a shape. So that shape would have a volume, and this is what we are going to study in this section. You will have multiple shapes, 2D shapes, right? You will have multiple shaded regions of this type, and the question would be of this type, find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. Okay, just imagine, are you getting the shape? Are you able to imagine that how are we going to get the bell shape after the rotation? Yes, is it making
Yeah.
sense to you guys? Please tell me. Yes, Aditya and Munja.
Yeah, it does make sense.
Okay, very good. Okay, I'll write down a question and then things would become very, very easy for you. Okay, so yeah, this is the question. Find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. This is the question. Let me make the diagram as well. Let's a different diagram for this question. it is y equals 9 by 3x plus 2, and the shaded region is 1, and this is the shaded region. This is x and this is y. Okay, please pay attention. What is the question? Find the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. Now in this picture, in this diagram, you do not know about the 3D thing. All you know is that this is your shaded region and it would be rotated to an angle of 360 degrees about the x-axis, and again you might get a bell-shaped type of a thing. You need to find the volume, and you'll see how to use integration for such questions when you've been asked to find the volume. Here the question is not about the area, the question is about the volume, but you'll see we are going to modify the integral and then find the volume. Okay, now I'll tell you. Let's say you were asked to find the shaded region. So you would have integrated. I need more space, so let me make some lines first. Okay. Let's talk about the solution. Let's say it's just an assumption. You were asked to find the shaded region only. In that case, you would have integrated. Please pay attention, from 1 to 2, and the function would have been 9 over 3x plus 2 dx. Okay, but here the question is not about the shaded region. It is about when the shaded region is rotated through 360 degrees about the x-axis. So you are going to do two things. You will square this and you will multiply pi. This is a fixed formula. Okay, I'll write down the fixed formula here as well, just so you know how to do such questions. Okay, every time when you have been asked to find the volume is the integration from a to b, they are the limits, pi into y squared dx. Okay, this is y, so we need to square y. That is why I squared y. I need pi. It's okay if I write it out. I'll write it down inside because that would make more sense to you guys. Okay, so that's pi, and the limits are coming as it is. Okay, so we need to do two further steps. We need to add pi, we need to add square, and now we are in the form of integrating it. Now this integration would not give me the area under the curve, it would give me the volume. Okay, so let's try doing this question. It is 1, 2, 9 squared would be 81, pi would be multiplied as it is, divided by the factor in the denominator would become 3x plus 2 square with respect to x. Okay, now I need to integrate it. So I can take this to the numerator just so I have the variable in the numerator, and then I can integrate it easily. 1, 2. 81 pi is going to come as it is. The factor would be 3x plus 2 minus 2 dx. Okay, now I need to add 1. This would be 81 pi. Now I'm integrating it. Please stay focused. 3x plus 2 and minus 2 plus 1 divided by the new power would be minus 1. I need to multiply it with what, Munja? The
3.
Derivative. Very good. 3. Excellent. So what am I going to get? Let me just write it down neatly. Okay, so I'll simplify this. 3 and 81 would be cancelled as well. So this is 1 times, this is 27 times. So we will get 27 minus 27 pi divided by 3x plus 2, and the limits are going to come as it is 1 and 2. Yes. Now I'll plug in the limits 1 and 2, and I want you guys to tell me the answer. Please simplify this and tell me the answer. Just plug in 2, then put a minus sign, then plug in 1, and then tell me the answer, please. I'll be waiting for your answers.
The first one is minus 27 pi over 8.
Very good. Yes, that is right. Minus 27 pi over 8. Very good. Then minus sign. And then what about the other one, Aditya? Could you tell me?
minus 27 pi over 5.
Very good. Minus 27 pi over 5. I'm sorry about my writing here. Okay, and once we'll simplify this, we are going to get 81 pi over 40 units squared or what?
Cubed.
Cube. Very well done. Excellent. Okay. So I'll repeat this and then that is it. So what are we doing here? Here we are using integration in order to find volumes of revolution. So why exactly it is volumes of revolution? Because we are rotating this shaded region to an angle of 360 degrees, that is one revolution. Once we are done with that, we are getting a 3D shape, and then we are calculating the volume of that. This is the formula for such scenarios. A and B are going to be same, pi would come, and y would be squared, and then whatever we are getting, we need to integrate it. So did you understand this, Munja and Aditya?
Yes, ma'am.
Okay. Very good. Okay, all right. Now let's talk about one last example and then that is it. Okay. This time the scenario is a bit different. I'll make the diagram only and then we can just, find the volume. Okay. This is what we have. This is the second question of this section. Question number 2, and you can say the last question of the lesson as well. Okay. It is y equals x squared. This is 2. And this is 5. Okay. What is the idea now? The idea is that you need to find the volume when the shaded region is rotated through 360 degrees about y-axis. Okay, this is the question. Acha, we need to understand multiple things there. Okay, now we know that how to modify our integral in order to find the volume. Okay, so how do we do it? We write down pi, we do y squared, we do dx, and we write down the limits. But something is different here. We have been discussing these types of questions as well, where the limits used to be on the x-axis and where the area used to be bounded between the curve and the y-axis. Okay, so things were different there. Munja, can you tell me how to integrate this just to find the area? We used to integrate it, and the equation used to be it used to be f of y. We used to integrate it with respect to y, and the limits used to be of y, right? This is how we integrate such scenarios. Okay, this is clear. This should be clear because we have done this. So once we know how to find the shaded region, all the other steps are same. Okay, so let's see how to find this shaded region. Okay, I will integrate it. The limits would be 2 and 5. This time the area is bounded between the y-axis and the curve, so things would be different. I'm not going to use x squared here. I need to use something else. Yes.
You have to use any variable.
Yeah, we need to replace the variable. Okay, so we used to have x there. Okay, now we need y here. So I will put y and then dy. Okay, wait a second. I'll tell you this way. Okay, look. What is the equation? The equation is y equals x squared, right? What if I make y the subject? What am I going to get? If y would be the subject, it would become, sorry, if x is going to be the subject, it would become under the root y. Yes?
Yeah.
Okay. So this is how we integrate it. So I will write down under the root y with respect to y. I'll repeat this again. This question is very easy, to not worry. We know how to modify the integral in order to find the volume. That is clear. The only thing under discussion is how to find this shaded region, because this time the area is between y-axis and the curve. So things are different. Initially or otherwise, if I had something of this type, this is again y equals x squared. Let's say it's 2 and 5. And let's say this was the area. I would have simply done this. But I cannot do this in this case because here the area was bounded between the x-axis and the curve. And here the area is bounded between the y-axis and the curve. Okay, so I cannot do the same step. So I need to use the previous knowledge, the way we have been integrating such questions, and then I can do it. Okay, right now this is good, but I need to modify the integral in order to find the volume. So I need to square this. I'll square this and I will add pi in it. Is this okay? Both of you, please tell me if you have understood this or not. Yes, please tell me if you have understood this or not. I'll simplify the integral meanwhile. Yes, Munya and Aditya, if this is okay or not, please tell me. Yes, Munya, did you understand this?
Yes, I did. So do we have to take a y out of the square root by, I mean,
Okay. It's okay.
y
It's
to the
okay.
power of half?
It's okay if you have not understood. Are you clear with the previous thing? Are you clear with the uh volume thing when the area used to be bounded between the x-axis and the curve? Are you clear with that?
Yeah, I'm okay with that.
Okay. So we'll start this discussion again tomorrow and I'll explain this again. Okay, don't worry
Okay.
about it. Okay.
Okay.
So Aditya, any questions from the previous topics?
No, ma'am.
Okay, so I'll stop sharing this. I'll stop the recording.